Hello, this is a probability video. So there is two chances. Either you will like the video or you will not like the video. So the chances is half half. Don't worry, I'm not going to give you this much basic things here. Keeping in mind that you know a little bit of basic probability, this video I'm constructing. Okay. Now, in order to do some advanced probability related topics which will be done in this set of videos, we will also deal about the random variables, the discrete and continuous random variables. There will be pth mean and all. There will be conditional expectation, joint probability distribution functions. There is weak law of large numbers and Lindeberg central limit theorem. So are a lot of things you are going to learn. So let's start with some of the basic formulations which will be useful for this probability chapter. For example, you know probability of this thing, union. So there are proofs, a lot of proofs I will be doing here. So the basic part is, what is A union B? That is both. U means both. That means, U or an intersection is coming for both. So now in this kind of cases, so you have the basic formula of P of A, and remember that although it's a very cliche thing, but it will be very useful. Total events and possible events or favorable. So this one is really a crucial thing. We'll be using it many times. Okay, even permutation combination also we will see that. For example, 39C13, 13C0 and 52C13. So there will be many answers like this. The cross-checking structure will be some of these two will be this, some of these two will be this. So this kind of many things according to probability pattern will be coming. So what do you mean by a natural assignment of probabilities? Simply, an assignment of probability is called natural or equiprobable if the assignment of each probability is have the same probability. So that is called the natural assignment. When all sub-events have equal chances of occurrence. That's it. Now, what is a structure? For example, we say probability of tossing a coin, another very advanced concept. We say probability of a coin is head or tail. That's it. So it's half-half. So simply if I toss a coin 4 times, according to probability it must be 2 heads and 2 tails. Isn't it? But in real life it never happens. Then what's the fallacy in the theory? You can find it. So people say, no, it's a game of chance. Then why are you saying half? Why are you saying 1/6 is the getting of 5 in a die? So if you toss it 6 times, there should be a 5. There may not be. So actually the concept is, if I toss a coin where n tends to infinity number of tosses, then probability of head tends to half and probability of tail tends to half. So if the total number of possible throwing of a die is tends to infinity, then this probability of getting a 5 is tends to, that means close to 1/6. So this one is a very, very important thing. So it's not for finite cases, it is applicable for infinite cases, and the common approximation we are allowing it for finite cases as well. Okay. And a probability always, here we need to keep in mind that probability of this thing I equal to 1 to n is summation of P of AI. So each event's probability together is the summation of the probabilities, which is called the additive axiom. A very important and crucial part which we'll be doing. Now, how you say this thing in probability. So this is nothing but this part. This has a name, and that is symmetric. Event A and B. Remember that this part is A minus intersection B. This part only is A minus B. This part is B minus A. I'm taking both. So A minus B. So A this B plus A B this. That's it. And simply you can see it's a disjoint set. Next part is with respect to probability that how to write only A occurs if there are three events. Three events are there, only A occurs. So A intersection B intersection C, and put these two like this. Any two occurs, so now any becomes a problem. So you need to write it thrice. This is a way of writing the probability. Any two. So this union, first time you remove A, then time B, third time C. That will be an easier concept. In the same way it is two or more. Any two or more happening, there every time is two is happening, any more. So write whatever you have here, union another event, that is P of A intersection B intersection C. So these are the similar and a very basic way of writing probability. For example, I'm going to discuss some basic theorems also. Like if B this, how to draw it? B and this is A. So B is completely inside A. This is a way to write. But this will be the case if it's, then this is the way to write. Okay? Now, what is this area? This is A intersection B complement. This segment is B only. So if I ask you P of A intersection B complement, so I will write it simply PA minus PB. And obviously probability of B is less than or equal to probability of A. So these are the two basic things of theoretic structure we will be needing for bigger theorems to prove. You may have seen this, like probability of A union B. You know the formula, I guess. Now you also know the probability of A union B union C. Now this advanced topic I will be giving you to the world of this. Let me write the thing for you. I know you know it, but still I am writing. This is A, this is B, this is C. This is AB, BC, CA, ABC. This part how? You see there is a pattern. First these two, then multiply, then 3, then the product of 2, then 3. So here also it will be starting with PB, PC, PD. First part. Then you take 2 together. So taking 2 together has a pattern. 1, 2, 3. Sorry. It is 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and 3, 4. So 1, 2 means AB, then AC, then AD, then BC, then BD, then CD. Plus, now if 2 are coming, so it is 1, 2, 3, 1, 2, 4, 3, 4, 1, 3, 4, 2. So 1, 2, 3 means ABC. Next it is ABD. Next it is CDA and last one will be CD B and minus P of A B C D. That's it. So this is the way of doing P of A union B union C union D's formulation. Another important extension of the additional theorem can be extended as, so this total part, how can you write it in the extensive format? So probability of, let me use red for this because we're going to remember, probability of A union of AI, I equal to 1 to n, that is A1, A2 dot 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 an is nothing but first one is this portion. So summation of P of AI minus, put a double summation because two things are coming, P of AI intersection AJ, this is I, this is J. Remember that I less than equal to J less than equal to n less than equal to 1. Okay, these two are equal actually. And this here I equal to 1 to n. Here also 1 to n. Now you have to take 3 together, so triple summation. So here the third thing is coming, 1 less than equal to I less than j less than k less than equal to n. So P of AI intersection AJ intersection AK. That's it. In that way we will be proceeding. And lastly we will get that the last term is really important. The last term is minus 1 whole to the power n minus 1 into P of A1 intersection A2 dot 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 AN. Okay, because the last term will obviously a minus, it depends. In 2 cases it is a minus, in 3 it's a plus, it's a 4 it's a minus. So if n is even, then it is a minus. If n is odd, then it's a plus. So these are the deeper way of going for the addition theorem of probability.